So we're still covering everything related to functions, and in this learning objective, we're just going to focus on how to make those graphs of our functions better. So in the previous learning objective, we kind of just plugged in some values, got some points, and made some inferences about what the shape should be. All right, now we're going to figure out how can we make them slightly better. And the way we're going to do that is using intercepts. All right, so we have our axes on our graph. Those are always going to be there, our x and y axis, and knowing exactly where our graph crosses these axes is going to make our graph more accurate, right? Because we'll know exactly kind of what's happening at those important values, right? And these spots where our graph crosses are known as an intercept. And so when we say x-intercept, that means when our graph crosses the x-axis. Y-intercept, that's when our graph crosses the y-axis. So what do all intercepts have in common? Well, if we're an x-intercept, we're crossing the x-axis, which is this horizontal line here. And what do we know about that horizontal line? All right, all our x-intercepts are going to cross through there. But what do they all have in common? Well, if they're all on that horizontal line, they haven't gone up or down off the x-axis yet at all. So they haven't gone up or down at all. That means that their y value is 0. So every x-intercept has a y value of 0. All right, so that's going to be useful when we start trying to find them. About y-intercepts, well, it's going to be really similar because y-intercepts are on this vertical line here. And for a y-intercept, we haven't gone left or right at all. And if you haven't gone left or right at all, that means your x value is 0. All right, so how is that actually going to help us find our intercepts? Well, let's say we want to find the x-intercepts for f of x equals 5x minus 2. Well, if it's an x-intercept, that means the y value is 0. Right. Well, f of x is equal to y, right, because that's our function notation, f of x equals y. So if we make y 0, that should be equal to 5x minus 2. Right. So the real simple kind of way of saying to find an x-intercept, you set your expression, your function expression, equal to 0. All right, so you'll do this for every single x-intercept you want to find, and now we just have to figure out how to solve this equation. So this is one of the things we'll learn throughout the year. Different types of functions require you to solve in different ways, but we solve equations like this. We add 2 to both sides, and we divide by 5. All right, so if we were graphing this function by hand, we would want the graph to cross the x-axis at 2/5, which is 0.4. All right, so this helps our graph be more accurate, so we know exactly where that kind of intersection is going to happen. All right, next we want to find all the x-intercepts for this function. Again, if we think about the last example, all we're going to do is take our expression, 6x minus 3 over 2x plus 1, and we're going to set it equal to 0. All right, so at this point in the semester, I'm not expecting you to be able to actually graph a full type of equation like this where we have this division between stuff. All right, we'll learn about this in a later unit. All right, but for now, we should know how to solve this equation. All right, one thing we've done a lot already when we're dealing with an equation with fractions, one thing we do is multiply both sides of the equation by the bottom of the fraction. And we do that because on the left-hand side, this on the top is going to cancel out with that on the bottom, and we're just going to get the top of the rational. On the right-hand side, we're taking this thing, this big thing, 2x plus 1, and multiplying it by 0, but it doesn't matter because when you multiply anything by 0, you get 0. All right, so remember this step. All right, there will be questions like this on the skill check, but you can just multiply both sides by the bottom of the fraction. Those will cancel out, and because you have it equal to 0, it makes it a lot simpler. But now I can add 3 to both sides, and then divide by 6. And remember to simplify your fractions if you can. 3 over 6 is the same as 1 over 2. All right, so the x-intercept for this thing, it's called a rational function, which we'll talk about later again, is 1/2. All right, so that's where that graph is going to cross the x-axis. All right, so here's your to try on your own. Find the x-intercept of this function, h of x. And here's the x-intercept I got. So again, x-intercept, set your equation equal to 0, subtract 9, divide by 3, And when you simplify that fraction, you get -3 as your x-intercept. All right, so now changing gear, we're going to change from x-intercepts to y-intercepts. If you remember back from that earlier slide, y-intercept means your x value is 0. All right, so our x value is 0 means I'm going to replace x with 0. So really another way of finding your y-intercepts is to say you're going to find f of 0. All right, I'm going to put 0 into my function. And we know how to do that. I replace all the x's with a 0. And 0 is the nicest value to plug in because a lot of these things will go away. So if I do order of operations, I'll write it out this whole time, but you can kind of see what's going to happen already. Then the multiplication, 0 plus 0 is 0, minus 2 is -2. All right, so when you're finding your y-intercepts, the simple way to put it is just, oops, if I can actually write it, plug in 0. All right, so if you just plug in 0 into your function, that's going to give you your y-intercept because we know our x value, our input, has to be 0. All right, so this is the same function we did before with an x-intercept, but now we're going to do it with a y-intercept. Again, that just means we're going to put in 0. Order of operations says I do the multiplications first. And I get -3 over 1, which is -3. So my y-intercept for this one is -3. All right, so y-intercept's pretty straightforward. Just plug in 0 and figure out what number you get. All right, so here's your turn. I go ahead and find the y-intercepts for this function. All right, and here's the answer I get 5 for my y-intercept. One small mistake that some people might make is with the exponents. All right, they might apply the square to the 3 as well and get like a 9 minus a 4 plus 5 or something like that. But remember, you square first, so 0 squared 0, and then do 3 times 0 is 0. So really when you're plugging in 0, all these terms with the x's are going to go away, and that makes it pretty simple to simplify after you plug in 0. All right, a couple notes. All right, when you're dealing with y-intercepts, you're plugging in x equals 0. Well, if I'm plugging in a value, I can only get out one value. So there's only going to ever be one y-intercept because they pass the vertical line test. All right, so when I'm asking you to find a y-intercept, you're only going to get one answer. All right, for right now, because of the types of equations we know how to solve, generally you're only going to get one x-intercept. But we are going to learn about functions in the future that can have multiple, generally 2 or 3 or something like that. So we can have more than one x-intercept, but for right now, you'll probably also only get one. I just noted it is possible to get more than one x-intercept. All right, another thing is to keep in mind, we're going to be learning about different types of functions throughout the year, but this fact does not change. Finding your x-intercept is always setting your equation equal to 0. Finding your y-intercept is always plugging in 0. All right, this is not going to change no matter what type of function you're talking about. So even if you start talking about quadratics and rationals and trigonometry and exponentials and all these other types of functions, these facts will always be true for all of them. All right, this is how you find x and y intercepts. All right, so time to practice. All right, see what types of functions you might be expected to do on the skill checks by doing the practice. All right, making sure you understand and making sure you keep the x-intercepts separate from the y-intercepts, and you're not trying to do the same thing for both or you're switching them up. All right, make sure you know how to find x-intercepts by setting your equation equal to 0 and finding y-intercepts by plugging in 0. All right, so go ahead and start practicing and take the skill check when you're ready.